Video assignment E1, Antiderivatives. Learning outcomes for this lesson. Following the completion of the workbook assignment and the in-class activities, the successful student will be able to 2. Calculate basic antiderivatives. Advice for mastering the learning outcomes. Recall the matching derivative property from section D3. If f prime of x equals g prime of x for all x in an open interval AB, then f and g differ by a constant on the open interval AB. That is, there exists a constant c such that f of x is equal to g of x plus c for all x in the open interval AB. A function f is an antiderivative, capital F is an antiderivative of little f, on an interval I if capital F prime of x is equal to f of x for all x in I. According to the matching derivative property, if capital F is an antiderivative of little f, then every possible antiderivative capital G satisfies the equation capital G of x equals capital F of x plus c, since capital F prime of x is equal to capital G prime of x, which is equal to little f of x. In other words, any antiderivative of little f must be capital F plus some constant. When you find an antiderivative, you are undoing the derivative. In other words, the function given is the derivative of some mystery function, and the antiderivative is the mystery function itself, with some uncertainty involved via the plus c. This next one is extra important. You can check every antiderivative problem. Take the derivative of your potential answer and make sure that you get the original function. The process of finding antiderivatives of a function is antidifferentiation or integration. So other verb forms, you could say antidifferentiate. Or you could say that you are antidifferentiating. The expression indefinite integral sign f of x dx is called the indefinite integral of f. It means find all antiderivatives of little f of x with respect to x. Another way to say this is find the most general antiderivative of f of x with respect to x. And this next point is read this integral symbol f of x dx equals capital F of x plus c as the indefinite integral of f with respect to x is capital F of x plus c. In that expression, little f is called the integrand. Dx tells you what your variable is. Do not leave it off. Capital F is an antiderivative of little f. And then c is called the constant of integration. Every specific value of c gives you another antiderivative of little f. Without the c, your answer would only be one antiderivative, not all of them. So you need the plus c. One of the most fundamental properties of antidifferentiation is the power rule for indefinite integrals. So when n is not equal to -1, the indefinite integral of x to the n with respect to x is equal to 1 over n plus 1 times x raised to the n plus first power and then plus c. So for example, the indefinite integral of x to the fourth with respect to x is equal to 1/5 x to the fifth power plus c. And you can check that with differentiation. Differential equations. A differential equation is an equation of the form dy over dx equals little f of x. To solve a differential equation, you determine the function whose derivative you see with some uncertainty via the plus c. In other words, you anti-differentiate to solve the problem. Initial value problems. An initial value problem has two parts. First, a differential equation, and second, a value for the original function at some value of x. In other words, an initial value. To solve an initial value problem, first solve the differential equation, and then use the initial value given to determine the specific value of c that results in the correct initial value. So a differential equation, you end up with a plus c, and with an initial value problem, you realize that that's really like a plus 5 or something. So in other words, you work out the exact value of c that's required to make your initial value work out. Sometimes you'll be told to determine an antiderivative capital F for little f, which has a particular value at a point. For example, find an antiderivative capital F for little f of x equals x squared, satisfying capital F of 1 equals pi. This is another way of stating an initial value problem. To solve, find the most general antiderivative capital F for little f, and then use the other information given to solve for the specific value of c needed to obtain the given value. Be careful with antiderivatives of sine and cosine. It's really easy to make a sign error because the derivatives and antiderivatives are only different in the sign sign plus or minus sign in the front. So be really careful when you're anti-differentiating sine and cosine.